All right, so we are going to continue our story. I want to ensure that you all can hear me. So I need a volunteer to just unmute. Just say, I can hear you, sir. And also, just confirm that you can also see the screen. Just anybody.
Good
Good
We are
afternoon,
seeing
afternoon,
sir.
sir.
you, sir.
I can hear you and I can see the screen.
Okay, thank you. All right, so yeah, we are continuing our story. Our mission here is to ensure that after this CodeCamp program, you are a world-class tech person. Nobody should confuse you. I am not here to try to, speak so much of English. I want us to really understand this thing. Even if you can explain it in Pidgin or in Yoruba language or in Igbo language, I'm fine. Intelligence is not really measured by how fluent you are in English, but of course, English is something that, is our, of course, that's just the way we have operating system. The human operating system is language. You understand? And that's why you understand, um, you need to understand why AI is very, 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 it's very interesting, something that you should not ignore. Because what AI has basically done is to hack our operating system. The only difference between Homo sapiens and Homo erectus and other species of whatever organism you have in biology is our ability to, you know, um, communicate, especially using different languages, can be sign language or written. Dogs, their communication is limited. There's a limitation to what they can do. And what is the differentiating factor? It is the brain, right? So the barrier of language has actually been lowered. That's why when you're talking about, coding, you have to choose a particular language. So what I am trying to do here is for you to really understand this thing. Okay, break it down. Even if you are new to the whole tech thing, at the end of the day, nobody, even people that study computer science, might even struggle to catch up with what you already know, because sometimes you don't really blame the lecturer because of the way the system is organized. You have only 3 months and everything, you have to meet up and everything, so they might not really have that time, and you know enter Code House to the rescue. So that's what we are trying to do using CodeCamp. And for the first time, I can say this is the first uh cohort that we're actually introducing DAIPODS, and it's very, very, very important, because these things, if you understand it, it's going to give you more confidence to now progress to any track, be it web, back end, and everything. When you hear certain terms, you know that, oh, naturally this thing makes sense and everything. So we started off talking about the computer, you know, just a quick recap where we started from and where we are today. So I like doing a recap, so that people will not be lost. So we talked about computer and being an electronic device. I'm sure people have digested that word electronic very, very well, because that's what we are going to be talking about today. It does 4 things: get, process, store, and retrieve what? Data, of course. We talked about the computers and the term, where did you need to know where it comes from, so that nobody will confuse you ever again. There's a school of thought that is the one who computes, used in the early 17th century. Alan, see it as someone that follows instruction. But in the real sense, the first use of computer professionally were for women in Harvard University Observatory that studied the galaxies. So I showed you, when we talk about studying the galaxy, the different methods that I use. So I had to just dabble a bit into the history of photography. I have wet photography and dry plate photography. So that dry plate is actually what they used in the so-called observatory, and they use the telescope to capture, shots, different shots. They expose it, and the light is kind of negative. The dark side is white and the, you know, um, the white that's supposed to be bright becomes dark. So you can see the dark spots you see are the stars that are glowing. And what they did is just to count galaxies and also the rate at which they are blinking. And they use it to try to estimate the distances of the stars from, you know, the Earth and all that. You can see an example I showed there of a report. You can see different marks on it, trying to do different calculations, how far, first of all, they are from each other and all that. So, and these are the computers, right? Human computers. There are women. So that's the essence of that story. Not because I want to teach you photography. So we move on to mechanical devices. We mentioned some of them. And fun fact, the father of computer is Charles Babbage, you know, as generally acclaimed, you know, who am I? I was not there. So he invented two machines, analytical engine and facial machine. These are all mechanical. And I said that we moved on to what? Electrical. And when you talk about electronics, we are not talking about using vacuum tubes. You know, when you send electrical signal to it, it comes up, you know, the relay will turn it off and on. And that is the essence of 1 and 0, the binary as we know it today. And we talked about how they consume spaces and we just made them smaller. And enter came back, the first personal computer without microprocessor, and also the micro N, the first personal computer as well, but this time the processor. And we had to tell the story how we move from vacuum tube to transistor to integrated circuits. And this is what the vacuum tube looks like. So this particular computer, if you Google ENIAC, you see it means electronic numerical integrator and computer. So this is the world's first general purpose electronic computer. And you can see illustration of the binary off and on, different configuration shows different things. And at the end of the day, we had to enter into the era of transistors, which is still the principle that is obtainable up to today. So we have, you know, emitting. I showed you how we have what we call negative depletion layer. But when you apply a positive charge, then the thing will go to flow from one end to the other. And that's what we call high state. So off is low state, on is high state. And kind of did the demonstration. So we talked about the logic gates. Started with the simplest. The only logic gate that has one input and one output is what we call the what? The NOT gate. So it actually gives you the opposite of, if the input is 1, the output is 0, output is 0, the input is 1. So we talked about the OR gates. OR is if one of the input is true, then the output should be true. And we talked about AND gates. Both the input and the output must be true. Sorry, both the inputs 1 and 2 must be true before the output is true. And then we talk about the NOR gate, which is a combination of OR and NOT. And we talked about the AND gate, which is a combination of, sorry, the NAND gate, which is a combination of AND and NOT. Okay. And then we talked about XOR. Okay, XOR is it is only one, okay, if both, okay, sorry, if 0, if both are the same, both the input and output are the same, it gives you 0. Okay, if they are different, it gives you 1. So when you attach NOT to it, it becomes XNOR. So if both inputs are the same, if they are 0, 0, then the output is now 1. So it's just a flip of, you know, the XOR. So we actually talked about the real life application, and then we dabbled into what the integrated circuits, having shown how off and on can be combined in different configurations using the logic gates. We talked about what problem the integrated circuit solved. Okay, they are smaller in size, they are more reliable, they are faster, and they consume low, less amounts of electricity. So we talked about packaging, two major categories of packaging. I mentioned it. through hole when you have the pin and you have to go pierce through the board. The board is actually what we are going to talk about today. When we talk about the motherboard and all those kind of things, don't worry. We are going to look at what is motherboard, what is it made up of, you understand? So we're going to break all those things into pieces today. And two major categories of packaging I've talked about: through hole, and then have the surface mount where you don't have to pierce the PCB. PCB, by the way, means printable circuit board. So we can see how we transverse from civilization 1950s to what we have today into ultra modern large scale integration. Most of you, aka microprocessor. All right, so we talked about digital and analog. I told you that analog are continuous signals, digital are digitalized signals in terms of having a discrete value of 1 and 0 instead of having continuously infinity value. So we have some computers that can measure some these analog signals. And of course, the computer we use today, we are defining computer in terms of 1s and 0. We are talking about the digital computer. And then hybrid, someone asked a question yesterday. I remember I was able to, kind of explain that when you have the combination of an analog and a digital, you get a hybrid, which is what is obtainable in some of the computers you have today. So finally, we started going into the computer itself. Now we have talked about the definition, the history, the things, the processor, the brain, and everything. We now have to start looking at the hardware and the software. This is what is going to mark the end of this first session. When we finish the hardware today, tomorrow we can look at the software and then we end. And then we'll continue with A, which is, is DAIPODS. So we are going to be done with D this week. So going into the hardware, we have to bring in the first slide and we'll drop it at the top right hand side there. You see, so we have to list the get, the process, and the store and the retrieve. For input and output, we have to treat them together because there are input devices and there are output devices. And for us to have a better understanding, we looked at human. It becomes very simple if you know how we coordinate our own activities. Okay, and we talked about our own hardware in terms of input devices. Of course, you have them listed there, and it is this input that we coordinate with our brain to make various decisions that we make. Now, bringing it down to the computer hardware, we talked about the physical things that you can touch: your earpiece, your earpod, your microphone, your keyboard, anything that you can touch is hardware. But anything that you cannot touch physically, like a piece of software that is running your Facebook, your WhatsApp, your Microsoft Word, your PowerPoint, your any app you can think of, there is no way you can touch it physically. So it is called software. If you remove software, the computer is useless. But if you have the hardware and you don't have a software that is running the computer, that is why in every definition of the computer, you must see these two terms. Okay. So when we talk about the software, you can categorize them into input, output, storage, and processing, which matches with get, store, process, and what retrieve. Okay. Now I mentioned something very, very important: peripherals. So computers cannot work alone. Again, if all computers are built to work alone, it will be very, very useless piece of device. Okay. If I can type all the letter in the whole world, I cannot print the letter. I don't know of what use it is. You can actually maybe send it via email and everything. But if you take your digital camera and you cannot edit it, another problem. And all these things, people have heard about the biometrics and stuff like that. You can see that different computer systems now have added another term: system. So there is a difference between computer and computer system. Computer system is, of course, the computer is at the core of it, but there might be need to, attach different kinds of devices to a computer for them to work together. For instance, in my own computer, I don't think I need a biometric device because I'm not capturing anybody. I'm not working for INEC. I'm not working for road safety. I'm not working for NIM. Is it Nigeria Information something something? The people that do NIN. So why do I need that thing that will take fingerprints and take your picture? But you see, in their system, it is added either through a USB, or you see that some of their system is built to have that special camera and even the fingerprint capture. So you can see the computer you are using might be different from the computer your neighbor is using. So depending on what the computer is meant for, the computer system is different. In another setting, we can be working as a team and we are all connected to the server. The server becomes part of the computer system because you have our RJ45 cables that we can connect and all that. So if you normally have an office where you print a lot, immediately you connect your printer to your computer, the printer, you will notice that you see the printer in your computer. You can access it and send the work to the printer to be printed. If the printer is not part of your system, you cannot print. So when we come to this part, we are not talking about if you want to listen to music, if your earpiece is wired, there is a jack, this thing jack that you can plug your earpiece and you listen to your music from your system. So that becomes part of your system. So all these things that you can either plug with wire or connect wirelessly, they are all referred to as what? Peripherals. So peripherals are part of your computer, but when they are added, you're not talking about your computer system. So I have to make that clear. So a lot of our output and input devices, is connected. So today we are going to take that story further. I kind of listed all the hardware and the software component and everything. So talking about processing. Now, when you connect all these devices, trust me, they talk to each other through various means. Okay. I remember telling you people that the brain of the system is the central process. That's why it's called central, because just like our central nervous system, you can see somehow the reason why I'm drawing this analogy is it makes it easier for you to understand. So we have the central processing unit, and there are three major components in the central processing unit. Okay, that is the brain of the computer. The most important component there is ALU. If somebody is asking you, if you have to narrow down and narrow down and narrow down, what is the computer itself? For me, I'll say is the ALU, right? Because that's where every computing happens. Okay. You have your commands. I'm going to talk about the cycle, in this call. So we have your control units as well, and then you have your memory units. So these are the three components. What does control unit does? It makes sure I mentioned bouncer. So whenever you wherever control unit is mentioned, just remember bouncer. Somebody that helps control and maintain certain level of order so that you don't probably crash the party. So see the party as where the logic is happening. If the room can only contain maybe 20 people, probably invites has already been given out to 20 people. So the bouncer is to ensure that 20 people means that the room has a capacity, just like the ALU will have a capacity to run. If the bouncer is not on duty, somehow a room that is supposed to be for 20 might end up having like 100 people. And of course, your system will start hanging and all that. So it kind of works hand in hand. And of course, the memory in this case, I mentioned it yesterday, you are talking about primary memory, because there's equally secondary memory, which is storage. We are going to talk about storage devices. Okay, I think probably that one might be tomorrow. So I want us to begin to understand the difference between primary memory, which is largely what a lot of people know as RAM. But there are other primary memories. We are going to mention them, by the way. So, but RAM is the most common primary memory. RAM means random access memory, meaning that it is a memory that is accessed randomly. grammar. But let me just explain it, Sha. If you check, a lot of us are living in various parts of Nigeria, right? Some people in Ogun State, some people in Lagos, some people in Port Harcourt, some people in Akwa Ibom and everything. But guess what? I am sure wherever you are living, if there is a kiosk, someone that is selling all these small food items and everything around your area, I am pretty sure somehow that one will be similar to the one in my area. Meanwhile, the person in Akwa Ibom State has never ever talked to the person in Ogun State. Okay, but somehow if you take a picture of these shops, they are going to be looking the same. So is it that at some point the kiosk owners came together and had a meeting? The answer is no. I'm going to explain it with this whole idea of primary memory. Now, if you notice some of those shops, cast your mind back, or after this call, enter the street and observe it yourself. You see that at the door of this, whenever they open, they carry all the sachets, okay, or whether it is a iron burglary proof or something, they carry it and just hang all the sachets there, okay. Then by the right hand side, if the person is selling garri or beans or rice, you see them, they will bring table, and put it there. Where do they normally sit? They don't sit, most of them, even if they are sitting inside, their seat is usually closer to the door. Now, if you check very well, there's a reason for that. Like I said, it's not because they had like a conversation on how this thing is supposed to be configured, but because of convenience, somehow they have found themselves doing the same thing. Now, the reason why this is happening is that the items that are bought often are always in front. So you are likely to have people coming to buy more of sachet. Of course, you are living a sachet economy, sachet milk, sachet Milo, and everything. So why is in front is because the woman can always reach out sitting down, okay, tear the sachet out and give you pay. But imagine if those things are inside the shop. What the woman is going to be experiencing is that every time you come, she's going to get up, go inside, get up. Okay, even if the shop started like that, by the way, after some time, the person will begin to change the algorithm. Okay, because think at all these algorithm things are just like abstract. No, this method I'm using is it working? All of a sudden, they'll find themselves rearranging their things according to what convenience. Now, primary memory can be likened to what I just described now. So you need to have a memory that is close to the arithmetic logic unit so that it can easily stretch out his hand or her hand or just collect information, process it, and take it back and drop it there. That is the idea. So you don't have to be accessing your hard drive, okay? So it is closer. That's why it's called random access memory. So it gives access to the CPU so that you can always, in fact, it's part of the CPU, by the way, somehow, but not inside the CPU. So the ALU will always reach out, do certain things. That is why the content, all those things we used to cram in primary school and secondary, oh, the content of random access memory is very volatile. But leave that grammar. What it simply means is that it is random and it's temporal, meaning that it is active while power is on. So if your battery is running low, you understand. That's why a lot of people tell you to save your work, right? In case you are working in anything. That saving of your work simply implies transferring what you have done so far from the random access memory to your hard drive so that it can be stored permanently. In case power goes, when power comes back, you can go to maybe my documents or any folder that you have stored that in. You retrieve your information and continue from where you stop. Because if you don't, temporarily, those things are housed in the random access memory, and there's nothing guaranteeing you that if power goes, if you are using something that a laptop, a device that the battery is bad, right, you're going to lose your information because it is stored temporarily in the random access memory. So it's not meant to hold information forever. So sometimes when you open your system and you open a lot of tabs, some people, when you open your Google Chrome or any internet browser, you see them opening tabs. Some people have up to 60 tabs open, 20 tabs open. Where do you think those tabs are? Those tabs are not stored in your this thing. It's actually kept in the primary memory. That is why if your system shuts down, okay, some of the browsers now has the feature of caching. We are going to talk about cache, sir. So, but let's not go there. Okay, so that is the primary memory. So nobody should confuse you about primary memory. That is why whenever you are buying any device, because I'm not going to be teaching this thing without relating it to general, principle. If you are going to buy a laptop, always check the RAM. Okay, make sure that the RAM is strong enough, because that is what is going to be storing your temporary information. So if you are going to be running heavy um, software, you need to have a strong RAM, probably from 8 gig, because if you have a small RAM, it is because it is the memory location where the CPU is going to be accessing frequently. It might start hanging. Your screen might freeze and everything, because at that point you have overpowered your control units. So that's why specs, you need to look at. We are going to talk about speed. We are going to talk about memory measurements. You need to understand what is gig, bits, and all those things. So having said that, we now move on to what we have today, right? What we have today is, we have talked about input and output, right? Fine. The question will be, so when I plug this my USB, when I plug this my earpiece, when I plug anything, how does this magic happen that somehow if I put my flash, you hear one sound and all of a sudden the flash will appear and all that, the music, how do we send, if I have a HDMI cable, okay, if I connect it, because when I'm talking about IT, I want to put it in proper perspective, not narrowing down to the laptops and everything. Even your decoder at home, it will have HDMI. The recent decoders have had HDMI and everything. If you open all the electronic devices, one thing you are going to see is what you have on your screen. Every electronic device, be it a radio, be it a television, be it your phone. If you go to phone, if you have ever repaired your phone, whenever they bring it, you see one card like that. The computer, you see motherboard and everything. So what you are seeing on your screen, you see lines that are passing from one place to the other. So I want to demystify all these things. What these things simply mean is that there are wires that are connected from one point to another point. So you see holes that are drilled. This is what you are seeing now, is like an empty PCB. It has been etched, right? So what it means is that olden days, you need to use wire, solder this point and solder that point. So when you open your olden days television, what are you going to see? Wire, 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 wire everywhere, moving, soldered and all that. They have devised a means of connecting one part of the board to another part of the board. Okay, so instead of having your capacitors, transistors, resistors, and all those components that are um, connected on the board, we now run the wire the way you see it on this diagram. So these are actually conducting channels, okay? So the green parts are non-conducting channels. The light green parts are conducting channels. Now, this is what we call computer what? Buses, okay? So if you look at these two diagrams here, you could see now, on top of this one that I just showed now, we have now started connecting what? Components. And you see the components, they have their own connectors, right? And you can see, if you look very well, you see these wires running from one part of the board to another part of the board. So we have this board now, and what it means is bus. So I even like the name, okay, because it is even relatable. Bus is carrying people from, commuting people from one location to another location. So I think it's even natural. So you don't even need to cram so much, the concept of what? The concept of bus. So what we are talking about here is, you know, whenever you plug something, we call it plugging it to a port, P-O-R-T, right? We are going to look at all those things. Now, there is a connection, okay, because there is an extension that you can actually attach that port to. So when you look at your laptop, what you are seeing, if you open your laptop, you see that that USB is connected to the motherboard. So once you do that, you understand what happens is that signals are transferred from that point to any part of the system, be it the CPU, be it the memory and all that, using what we call the buses. Okay? The buses, transmit data from one location to another location. There's no other definition other than that. Just take that. Okay? Now let us talk about categorization. Okay? For context, you need to understand that buses are categorized as shown here, okay, based on their roles. So we have what we call system buses. In the next slide, I'm going to show you system buses. They are known as internal buses, right? So system buses are internal buses, okay? They are used to move. Remember what a bus is, oh, transmitting data from one location to another. So when you hear internal bus, right, it's simple. Don't overthink it. It's going to be moving, transmitting data from one point inside the device to another point inside the device. Simple. Okay? So what are those locations? Then you're going to be talking about your CPU and your memory. You can see how easy these things are. So you can transfer it from your memory to your screen, from the screen to the memory, from the mouse to the memory, from the memory to the CPU. Or sorry, not for the mouse. Mouse is external. So whatever that is happening in that, that is happening in what we call the motherboard. Okay, I hope you are following the story. So the motherboard contains buses and houses a lot of components, and the buses are responsible for transferring data from one location of the motherboard to the other location of the motherboard. Okay, now the second category is what we call expansion buses. So system buses is the same as internal what? Buses. Okay, we have expansion what? Buses. Okay, but let's talk about the system buses, because the next slide, so that you don't get confused. The system bus is actually divided into three. Okay, meaning that the three things are actually what is being transferred. So you have your data bus, you have your address bus, and then you have your control bus. We are going to see it in the next slide. Okay, so expansion buses. Now, they are called peripheral buses. Now, if they mention peripheral, if you have been following this nice story, it wouldn't confuse anybody, right? You can see expansion, also called peripheral buses, comma, extend the system to connect additional what? Devices, including peripherals. So you can see, don't confuse yourself. These things are simple. So here at the peripheral, however you connect your system and everything, you can see the particular thing that is responsible for coordinating your mouse, whether it is the wireless mouse or wired mouse, you see it moving on the screen. Okay, all those things, it is made possible by expansion bus. Okay, so that is how simple it is. And then we now have what we call universal serial bus. Of course, everybody knows USB, but probably this might be the first time of hearing the full meaning. USB cable. We are going to actually, there is a topic on USB. We are going to treat USB separately on this call, because some of you, oh, type A, type C, type C, don't worry, we are going to come to that. You are going to know why it is type A and type B and type C. That's why this is we are going to tear everything, nothing confusing. So in a computer architecture, a bus historically um, is also called a highway. I'm now reading what is on the right hand side of this slide. Is a highway, is a data bus, is a communication system that transfers data between components inside a computer system or between computers. Now, when you talk about inside, you're talking about system buses. When you're talking about between computers, you're not talking of what? Expansion buses. It encompasses both hardware, wires, fiber optic software, including communication protocols. We are going to talk about communication protocol in the letter O. So it is its core, right? The bus is a shared physical pathway. That's why I showed you the picture. Okay, it's physical. Let me show it again. This is how it looks like. You understand? It's a physical pathway, typically composed of wires. I've explained it. All right. Traces of circuit boards or bus bars, whatever you call it, is simply the what? The conducting part of this whole thing. Okay. Allows multiple devices to what? Communicate. Now you see why the computer is efficient. So this is um this thing I was talking about. System bus now, it's subdivided, right? Into, you have your data bus, you have your what? Address bus, and you have your what? Control bus. So let's just talk about data bus. Data bus, of course, ones and zeros and everything. You're going to talk about in this class today, you're going to break down the whole idea of ones and zeros. You understand? So the data bus, connects from the RAM to the CPU to all the everything. When you are typing your text, even on your phone and everything, what is happening is it is transferring signals via your data bus. So what prints on your screen depends on what you type on your keyboard. So now in your data bus, if it is one wire, let me just use one wire because it is relatable. Okay, it carries 1 bit of information. If it is 8 wires, it carries 8 bits of information. If it is 64, it carries 64 bits. Ever wondered why some systems are 32 bits and some systems are 64 bits? Now you begin to understand what these things mean. It means that the buses in this system is in such a way that they have 32 wires that can carry information simultaneously. I hope that is becoming clearer and simpler. Well, is it 64-bit system? Is it 32-bit system? That is it. So one of these buses will carry what? Most of them have a configuration of what? Having 64, in. So if your system has that kind of configuration, it means you are using a 64-bit system. If it has 32 cables, wire is using 32 distinct bits. Let us go to address bus. Okay. For address bus, you'll be wondering, what is it carrying? It's carrying memory address, because in your system, everything is about memory. Okay. It has a way of putting information available. So when you connect your external hard drive, you have your internal hard drive, those things. So if you want to access information, what controls the flow of that location where different things are, we are no longer talking of just transfer of data. We need to equally be able to transmit the address location so that the command will be able to reach that particular address. So the second type of bus is address bus. The last part of it is what? The control units. Okay. The control bus. So the control bus, if you check the control bus as well, what it simply does, okay, it sends control signals, because computer system is full of control. Your mouse, your printer, your keyboard, and everything. So it helps you to, manage signals that are sent from one part of the system to other. So they did not want to combine all these things into one bus. So they have to separate it to But so remember, we are still dealing with what? Internal bus, okay? A system bus is a single computer bus that connects the major components of the computer system, right? Combining the function of the data bus to carry information, an address bus to determine where it should be sent to, or where it should be read from, and then the control bus to determine its operation. Okay, so that is what we have there. Different pictures showing you how it works. You see, this one is just showing the schematic. This other one is showing you, okay, if you have CPU, you still have the address bus. Okay, now you have external bus. We are going to talk about external bus. External bus is simply, I've talked about it before now. It allows communication with external devices, right? So we're going to look at some of the external devices, but there are some concepts, okay, that I want to introduce. There's what they call parallel bus and what they are called serial bus. Parallel bus allows, okay, information to um, simultaneously be transferred through the bus. Like if you have, I talked about 16 bits, 8 bits, and all that, meaning that each of the line, okay, see each of the bit as a line. So if you have 32, that's the only way you can understand this thing. So imagine 32 bits bus as a bus that has 32 lines, and different ones and zeros can pass through those 32 lines at the same time. So that's what they call parallel bus. So you have serial bus, that cannot happen. It has to be one after the other. So parallel bus is mostly used when you are dealing with something like internal hard drive, external hard drive, and everything. Serial bus is mostly used when you're talking about transmission between the CPU and the random access memory. And of course, you guys know why, because there has to be control. If you send everything at the same time, there might be a problem. We are going to talk about multi-threading and multi-processing and multitasking very soon. So, but we are going to take it one step at a time. So, please, nobody should confuse you about how things move around the computer. Okay? It's simply buses. Remember, I am not teaching you this thing so that you can start producing bus or motherboard or something. It helps a lot of people because in this whole IT space, a lot of people might, even from this DAIPOD, decide to go into hardware and system administration, right? If you are going into system administration, server administration, IT support, brothers and sisters, you must know all this is I'm talking about. Your organization, you are going to be called, even if you are not in. See, this is what differentiates you from other people. You know, when you have finished this diapers, you understand, okay, maybe the problem my guy is having is this. Even though you are not employed to do that thing, you become a problem solver. You begin to tear these things down. So the next thing we are going to talk about today is information, in brackets, data processing, because remember, we are still talking about CPU. So what I've just done now, I've explained how the CPU was, the component of CPU, and I've equally explained how the CPU is connected to it, because somebody needs to understand how the brain is connected to every part of our body using the nerves. Okay, so the nerves is what transmits signals in our body. What the nerves does is exactly what the buses does. So you need to understand that before we go into the actual processing. So today we are going to look at what? The information processing. What is data? Right? Data can come in different forms, right? It can come as a text, it can come as an image, it can come as sound and signal. I am not sure, apart from this thing that I've written here, if there are other, you know, forms that data exists. If you check very well, these are the major form that data exists, right? So we need to talk about how the computer manipulates each of these form of data, because either we are imputing text or image or sound or video or signal, nothing else. So the representation of these categories of data, differs, right? The way you represent text, differ. The question is, why should they differ? They will differ because the only language that the CPU, which is the inside the CPU, you have the ALU, recognizes is the transmission of 1 and 0. Remember the concept of off and on. So it is today that we are going to see how all the games, all the Netflix, all the YouTube, all this thing goes back to the same 1 and 0. Okay? Today we are going to tear it down. Okay, is that what it means? So when they say binary, oh, okay, that's what it means. So number one, for text, okay, in chemistry, you know that they have the smallest unit of blah, 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 blah. They call it an atom, right? In living things, they say the smallest atom, they call it a cell, okay? So even in information technology, there are terms.
I'm speaking into over 4. I need to say LMS. You don't, I don't check, you don't want to check the Discord. So we LMS sleeping, but
Okay. All right, let me continue. So so the unit is important. Like I said, when you're talking about physics, you talk about atoms, you talk about molecules and everything. So please don't overthink this thing, right? We are going to break it down. For text, okay, we are going to be talking about bytes and bits, and from images, pixel, and all that. See, how does computer represent information? Just watch what is going to happen. Let's go to the first one, text. Okay, how do we talk about ones and zeros? Okay, let us test. Now, if you are typing a text, you are texting someone, okay, you are pressing your keyboard, but something is, if you are using WhatsApp, you are seeing A, B, C. Okay, if I want to say hello, HELLO, fine and everything. See, I want you to understand, the computer does not understand 1 and 0. Sorry, does not understand, the computer does not know what H is. So when you press H, right, what you are simply doing through the serial bus, remember, I want to connect all these things, is that there is a keyboard. Let me use my laptop. There's a keyboard. That keyboard has a connector. That connector is attached to the motherboard of the PC. So whenever I press A or H or any letter, what happens is that a set of 1 and 0 is sent through this the bus to the CPU, and the CPU will interpret it and send it to the screen, and the screen will print A or B or C. So the system, as we know it, does not know A, does not know B, or does not know C. So that is how, when you talk about ones and zeros and everything, that is how the system simply represents information. So we are going to do some exercise. I'm going to show you some of these things I'm talking about, right? Now, if the screen is still visible, I want to introduce you to what we call ASCII. ASCII stands for American Standard Code for Information Interchange. This is the beginning of the whole idea of transmitting information, right? Now, the ASCII, if you look at this slide that I'm showing you, it starts from 0 and ends in 200 and what? Sorry, 127. That is delete. Okay, meaning that if I want to send this signal, and press my keyboard, something is happening. Now, let me give you an example of a signal. If I have a roommate, I want to break this thing down. If I have a roommate, right, we can have our own code on how we want to knock on the door, right? Probably, I don't want to be, I want to tell you what can I, okay, a very good example now is that two of us are guys, and I have a girlfriend, and I'm coming with my girlfriend. We can have a code on how I will knock on the door, and my roommate should know that, okay, I am with someone. Probably if you are not dressed, you have to get dressed. Okay? I can do something like this, something like that, maybe 2 knots. Okay. Now, if there is another thing, danger or something, so however you people have decided, you can create your own code. So when you create your own code, what happens is that the important thing is the person that the code is meant for really understands it. So let me go back to the ASCII. It became a standard. That S in ASCII is representing standard. Just like two of you, the two roommates have a standard of sending information without talking, right? ASCII developed a standard so that when we type on our keyboard, it's going to print certain things on the screen. So now, 0 stands for null. You can see I'm now reading it down. 1 stands for what? Start from the head. You see, 1 does not mean 1 in the actual sense. Okay, so this is the standard. Okay, so when if you look at this thing, you see that the space bar, okay, is even number 32. The exclamation mark is number 33 if you look at it. So we have what we call the decimal representation. I have what they call character, and then we are going to be doing decimal to binary. And this is something that we did in secondary school, even though they did not really tell us that it's all about the computer, but it's fine. No wahala. So you can see, if you follow this thing down, you are going to see that capital A is even different from small a, or upper letter case of A is different from small letter case of A. The decimal value for the upper letter A, if you look at it there, it is 65. The decimal value for the small letter A is 97. So meaning that when you hold shift and press A, and when you release shift and just press A, in these two configurations, you are sending different set of signals to the board. And what are those signals? So we are going to look at some of them now. Okay, let's just do a little exercise so we understand what we are talking about. So I'm going to pull up a slide, not really a slide, Sha. So if you can see my screen, so I want to demonstrate something. So if you look at this, the question is, okay, let me duplicate this slide to explain what I want. Okay, let me use this slide. I'm going to clean up everything here. Okay, I'm going to clean up this thing here. Okay, so look at these boxes. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now these boxes, please follow this thing. It's very simple. This box, let me color this one red. Okay, so that the one that is red now, okay, is what we call the smallest unit, okay, of information, and it's called a bit. Small letter, sorry, small letter. So follow me. This is a bit, okay? This is a bit. So when you hear a bit, is the smallest unit of information. Okay, there's a difference between smallest units of information and smallest unit of data. I'm going to clear these things now. So a bit means a memory location, right, that can take only 2 numbers. It can either take a 1 or a 0. Okay, and 2 of them will not be occupying this red box at the same time. Okay, so is either 1 is occupying this box or 0 is occupying this box. And this particular box, whatever is occupying it is referred to as a bit. Okay, that is the smallest unit of information. That is a bit. Okay, now I want to cast your mind back to when we talked about transistors. Remember, we are showing off and on. Okay, we started with the vacuum tube and everything. Now we are bringing back that principle now. So when this box is on, it is in the high state. It assumes the value of 1. When it is off, it assumes the value of 0. Okay, so what happens is that, of course, you have 1, 1, 1, 1, 1 here. This is a configuration. Okay, let me just remove this. You understand what ASCII is all about. Okay, let me write ASCII on top of this place. Okay, now what it means, remember I told you, if we had only one box yesterday, I told you can, sorry, if we had only one box yesterday, I told you there are only 2 possibilities in this one box, which is called a bit. Okay, there are only 2 possibilities. Is either it is 1 or it is what? 0. Okay, that's one configuration. I remember telling you yesterday that if we have 2 boxes like this, okay, we are going to have, okay, if you have 2 boxes like this, let me zoom in. We now have 4 possible possibilities. 4 possible possibilities. Okay, 4 possibilities. Let me make it very interactive. Okay, I'll reduce the font size. All right. So now, either 2 of them are off. So I will write 0, 0. Okay, that's one configuration. That thing I explained is I'm going to do it now. 2 of them can be off. Okay, another configuration is 1 can be on and the other one will be off. So we have what? 1, 0. Another configuration is both of them, this one can be on and this one can be what? Off. So in this case, I will now have what? 0, 1. Okay. Then the 4th case is that both of them can be what? On and on. So this is 1 and this is 1. So I have what? 1, 1. Ladies and gentlemen, with these 2 boxes, we can only have 4 combinations. I can tell you that there's no possible combination again you can have with these 2 boxes. Trust me. Right? Now, if I make the box 3, if I add another box 3, what I've eventually done, I am creating what? 3 bits. This is 1 bit, this is 2 bits, this is 3 bits now. So I'm creating 3 bits, meaning that each of the bits can either assume 1 or 0, 1 or 0. So the first combination for these 3 bits, we now have 0, 0, 0. That's 1. That's first configuration. You can have this one, 1, 0, 0. This is another combination. Okay. We can have 0, 1, 0. Okay. This is another combination. You can have 0, 0, 1, 0, 0, 1. So you have 0, 0, 1. Okay. Then another one you can have is 0, 1, 1. Okay. 0, 1, 1. Okay. We can have 0, 1, 1. Another one we can have is 1, 1, 0. We can have 1, 1, then 0. Okay, so let me write it here as well. We can have 1, 1, 0. Then which other one? We can have 1, 1, 1. Yes. We can have 1, 1, 1. 1, 1, 1. So this is all. There's no other combination that you can get. So what does it mean? right? What it means that what I've explained now is that if you have sorry, sorry, if you can hear me, hold on. Sorry, I had some this thing. So let me just continue, please. Now, what we are going to see, can I still be heard? All right. So what I'm trying to explain now is, okay, when we had, let me go to another, okay, I think I should just stay here. When we had one box, okay, when we had one box, we had what? Two possibilities. Okay. When we had two boxes, okay, we had how many possibilities? We had four. Possibilities are like combinations, right? We had four. When we increase the box to three, we had nine possibilities. That's the last one we did. I don't want to continue. I just want to use this to show something. So what is the pattern here? Okay, the pattern here is, if we call this one n, if we call this n, right, the number of outcome, how we can get this is, we are going to say that it is n raised to power what? 2. Okay, so if n is 1, the outcome will be 2. If n is 2, the outcome will be 4, because it is now, okay, it is now, so let me shift this one a bit. Okay, so in this case, it is 1 raised to power 2. Okay, in this case now, okay, n becomes what? 2, right? Sorry. In this case, n is now what? 2. N is now 2. It is now 2 raised to power 2. That's how we got 4. In this case, n is now, why is this thing doing like this now? N is now 3, right? So it is 3 raised to power 2. Okay. So why I did this thing is that you don't need to continue guessing, what it will be if you keep on adding boxes. So if n is 4, I don't need to come here and come and be doing, okay, if I add another box here, I will start doing combination. This is permutation and combination, by the way. So I will now start doing something like 0, 0, 0, blah, blah, blah. No, you don't have to do that. If you know this already, that's fine. Meaning that if this is 4, okay, if this is 4, okay, 4 boxes, you can already guess what the possible combinations are. Okay, you can only guess what the possible combinations are. So it is going to give you 16. Now we are going to do something with them. Yeah, I believe my screen is visible now. All right, so now we have these boxes. Now I'm going to bring up all these numbers. Please, when we talk about binary number, okay, we use either 1 or 0. Okay, so if I bring up these two numbers, what this thing simply means is that you know that when you talk of decimals, if I put these numbers on top of these boxes, let me delete all these things I've done. I think the point has been made already. Okay, let me delete this point. So I can on any of this number, I can off any of them. So the essence of this is that these things on top of here, we did it in mathematics, but I'm going to do it in a different way. When we say 100, it is 1 times 2 raised to power 1, 1 times 1 raised to power 2, 1 times 1 raised to all those things that we did in binary. This is how it is done easily. Because this is like 100 tens and units, okay? You know that in this thing, you have units is to the right hand side, then you have tens, then you have 100, then you have 1,000. This is how our decimal number system works. Okay, in this case, you are starting from right to left. In this case, it's the same thing. So in this, when it reaches 1 or 0, it moves to the next one is actually double of the first one. So you have 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. Now, what we have here is that what it simply means is that, okay, I can on any of them, and any combination I get is what transferred kind of was translated into the decimal. So let me show you example. Capital A is 65. I'm going to give this example, then tomorrow I'm going to continue, please. Capital A is 65. Okay, so because capital A is 65, if we want to represent capital in such a way that this thing, we are going to ask ourselves, which boxes, okay, can I on, and which boxes can I off for me to get 65? Okay, so if you look at the top here, what I need is a combination of 1 and 64. That's why they are red. Okay, so it's combination of 1 and what? 64. That will give me 65. So what we are sending to the CPU is anyone that is red is 1, anyone that is blue is 0. So I'm sending 0, sorry, 1, 0, 0, 0, 0, 0, 1. So this is capital A. That is what it means. Okay, capital A, which is what? 65. Because a combination of 64 plus 1 is going to give me what? 65. Okay, so this is capital A. Okay, if you go to our this thing, capital B is 66. Okay, now I'm going to go back to this. How do we get what? 66. 66 is going to be 64 and 2. So I'm going to on this 2. I'm going to off 1. Okay, I'm going to off 1. So in this case, what we have now, we are going to have, you see, the code has changed. The binary code is now 100010. This is what? My capital what? Capital B, and this is what? 66. Capital C is what? 67. So how can we get 67? I'm going 64, 65, 66, 67. So I'm going to on this one as well. Okay. So if I on it now, I'm going to have what? 10000011. This is capital letter what? C. Okay. So ladies and gentlemen, I'm going to stop here. I'm going to continue exactly at this point tomorrow, and then we are going to look at after letters. We are going to look at colors. Okay, I'm going to look at yeah, Unicode, ASCII code, talk about decimal and everything, go to RGB and stuff. So please, I have to have a hard stop here. And please, let's join the same time. I'm sure probably tomorrow I might extend the time a bit just to make up for the little distance. Thank you so much for joining. Yeah, thank you.